Hi everyone, I'm Dr. N.Senthil, Associate Professor, Computer Science Engineering. Great pleasure for me to welcome you all for learning this session. In this session, topic to be covered is technologies of distributed computing under Unit 1, distributed and cloud computing. At the end of Unit 1, the students will be able to describe the core features of parallel and distributed computing in cloud. At the end of the session, the students will be able to understand the various technologies for distributed computing. The relevant technologies that provide concrete implementation of interaction models, which mostly rely on message-based communication. They are remote procedures called RPC, distributed object frameworks, and service-oriented computing. In this session, we will discuss about remote procedure called RPC, distributed object frameworks. Also, I will brief the examples of distributed object frameworks that are Common Object Request Broker Architecture, CORBA, Distributed Component Object Model, TCOM, COM1, Java Remote Method Invocation, RMI, and .NET Remoting. Now we will see about remote procedure called RPC. It's the fundamental abstraction enabling the execution procedures on client's request. RPC allows extending the concept of a procedure call beyond the boundaries of a process and a single memory address space. The called procedure and calling procedure may be on the same system or they may be on different systems. The important aspect of RPC is marshalling and unmarshalling. This diagram shows the major components that enable an RPC system. The system is based on a client-server model. The server process maintains a registry of all the available procedures that can be remotely invoked and listens for requests from the clients that specify which procedure to invoke, together with the values of the parameters required by the procedure. RPC maintains the synchronous pattern that is natural in IPC and function calls. Therefore, the calling procedure thread remains blocked until the procedure on the server process has completed its execution and the result, if any, is returned to client. An important aspect of RPC is marshalling, which identifies the process of converting parameter and return values into a form that is more suitable to be transported over a network through a sequence of bytes. The term unmarshalling refers to the opposite procedure. The marshalling and unmarshalling are performed by the RPC runtime infrastructure, and the client and server user code does not necessarily have to perform this task. The RPC runtime, and on the other hand, is not only responsible for parameter packing and unpacking, but also for handling request reply interaction that happens between client and server process in a completely transparent manner. Therefore, developing a system leveraging RPC for IPC consists of the following steps: or design and implementation of the server procedures that will be exposed for remote invocation, registration of remote procedures with the RPC server on the node where they will be made available, design and implementation of the client code that invokes the remote procedures. The client process program A called the registry procedure C, which is available in RPC registry service of server process program C. distributed object frameworks which extend object-oriented programming systems by allowing the objects to be distributed across a heterogeneous network and provide facilities so that they can be coherently accessed through they were in the same address space. This diagram illustrates the distributed object programming model, an instance that created in Node A, which asks for reference in remote reference module to call the method that available in remote instance of Node B through object skeleton with object activation, and then return the object reference to object proxy of Node A. Next, the object proxy in Node A passing the values to the object skeleton of Node B. The executed object passing the returned values to the Node A instance through skeleton and object proxy. Under the examples of distributed object frameworks, first example, Common Object Request Protocol Architecture, CORBA, is a cross-platform and cross-language interoperability among distributed components. CORBA is a specification introduced by Object Management Group (OMG) for providing cross-platform and cross-language interoperability among distributed components. The specification was originally designed to provide an interoperation standard that could be effectively used at the industry level. The current release of the CORBA specification is version 3.0, and currently the technology is not very popular, mostly because the development phase is a considerably complex task, and interoperability among the components developed in different languages has never reached the proposed level of transparency. A fundamental component in the CORBA architecture is the Object Request Protocol (ORB), which acts as the central object bus. Second example, Distributed Component Object Model (TCOM) is a Microsoft technology for distributed object programming before the introduction of .NET technology. TCOM later integrated and evolved into COM1. It's a solution provided by Microsoft for distributed object programming before the introduction of .NET technology. TCOM introduces a set of features allowing the use of COM components beyond the process boundaries. A common object identifies a component that identifies a set of coherent and related operations. It was designed to be easily plugged into another application to leverage the features exposed through its interface. To support interoperability, COM standardized a binary format, thus allowing the use of COM objects across different programming languages. TCOM enables such capabilities in a distributed environment by adding the required IPC support. Third example, Java Remote Method Invocation (RMI) is a technology provided by Java for enabling the RPC among distributed Java objects. Java RMI is a standard technology provided by Java for enabling the RPC among distributed Java objects. RMI defines an infrastructure allowing the invocation of methods on objects that are located on different Java virtual machines (JVMs) residing either on the local node or on a remote one. As with Corba, RMA is based on skeleton concept. Developers define an interface extending the java.rma.remote that defines the contract for IPC, that is interprocess communication. Fourth example, .NET remoting is a IPC, that is inter-process communication among .NET applications, a uniform platform for accessing remote objects from within any application developed in any of the languages supported by .NET. Summary of this session is we learned about various technologies for distributed computing. I hope you found this lecture is more informative. Thank you and have a nice day.